Why is a limit used for golden ratio calculation? Imagine trying to find the perfect balance point between two numbers that keeps getting closer but never quite meets. That's what limits help us do in math. When we talk about the golden ratio, we're really asking how close can two numbers get to a special number as they grow larger. The golden ratio is about 1.618, and it's an irrational number. That means it can't be written exactly as a simple fraction. Instead, it's the solution to a quadratic equation. But how do we find this number using sequences? That's where limits come in. Think about the Fibonacci sequence. It starts with 0 and 1, then each new number is the sum of the two before it. So it goes 0, 1, 1, 2, 3, 5, 8, and so on. If you take any two consecutive Fibonacci numbers and divide the bigger by the smaller, the ratio gets closer to the golden ratio as the numbers get bigger. At first, dividing two Fibonacci numbers doesn't give you exactly 1.618. But as you keep going further in the sequence, the ratios inch closer and closer to that number. This is because the ratios of successive Fibonacci numbers approach a specific value. We call this process taking a limit. A limit is like saying, as the sequence goes on forever, what value do these ratios get closer to? It's a way to handle numbers that never quite reach the exact value but get really close. Since the golden ratio can't be exactly reached with finite numbers, using a limit helps us understand its true value. This approach is important because it connects the idea of infinite processes with real numbers. It shows how the golden ratio naturally appears in growth patterns and shapes in nature. The limit process helps us see how simple sequences like Fibonacci can reveal complex, beautiful patterns. So, in short, a limit is used to calculate the golden ratio because it allows us to find the value that the ratios of successive Fibonacci numbers get closer and closer to as the sequence continues forever. It's a clever way to approximate an irrational number through a process that involves infinity. This method links the abstract concept of the golden ratio to real-world patterns and mathematical structures we see all around us.